Welcome to a new video from MC Mastery Path. This is Mo, and I'm glad to be your presenter today. In today's video, we're going to be exploring how we can fine-tune large language models on silicon-based Apple devices using the MLX framework. Today's video is going to be split into 4 parts. The first part is going to be setting the coding environment. In the second part, we're going to be exploring how we can create and import data for the fine-tuning process. In the third part, we're going to be exploring how we can train our desired large language model and then test it and validate the results. And in the last part, we're going to be exploring how we can save the adapters for the fine-tuned large language models and then convert the fused large language model into GGUF format. All the code for today's video is available on my GitHub repository, which is available through github.com/moreshow93/MLX_fine-tuning. When you open this repository, you'll find a lengthy README file, which is going to take you through the whole process. It lists the acknowledgements and also has a thorough table of contents, including all of them parts, and also delving deeper into each and every single part by listing what steps need to be followed alongside the relevant code. In the repository as well, there is a Jupyter notebook file which contains all the code that's going to be presented in today's video, alongside a model file that is created for the fine-tuned model and helper Python file to convert CSV files to JSON-L, which we're going to be explored in due course throughout this video. And now, without further ado, let's get started. The fine-tuning process that we're going to be following in today's video is going to be reliant on the following. We need first to install a number of them dependencies and piece of software, which we're going to be exploring in a little bit. And then once we have this piece of software installed, we can then download our desired model from the Huggingface website, and then using the MLX framework, we can easily convert the Huggingface model into an MLX model. We're going to be using the low-rank adaptation method to fine-tune the MLX converted model so that we can have an adapters or trained adapters. We're going to then use the MLX framework to fuse the training adapters with the MLX converted model. And then the last piece of the puzzle is going to be converting the fine-tuned MLX model into GGUF format to be used on other third-party piece of software such as Ollama and Open WebUI. Starting with setting up the coding environment, we need an integrated development environment, and my IDE of choice is Visual Studio Code. You can easily download it for your operating system by going to code.visualstudio.com/download. We also need a programming language, and our programming language of choice on which the different dependencies and libraries are built on is Python. So we can download Python for Mac by going to python.org/downloads/macOS, and you can download any version that you want. However, I suggest that you install any version that is 3.11 and later so that it has the full support for all of the packages that we're dealing with today. The third piece of software is Homebrew, which we're going to be using for installation of other bits and pieces. Installation of Homebrew is fairly simple. Just go to brew.sh and then you copy that link and open a terminal window, and then you paste it, then press enter. The fourth piece of software that we need is Git. Git is quite important because we're going to be using a number of them GitHub repositories, and we need to clone them onto our PC. And in order to do that, you can go to git-scm.com/downloads/Mac, and then you can install Git using Brew. Or what you need to do is Brew install Git and press enter, and it's going to be installed on your machine. Next is Ollama. Ollama allows the end user to chat with large language models locally on your machine. You can go and download Ollama by going to ollama.com and then press on the download icon. You're going to have a DMG file which you're going to have to run and then follow the installation procedures. There are a wide variety of models that are available on Ollama. You can go to the models tab here, and then you can explore a number of them models. Dealing with Ollama is quite simple and straightforward. So once you have Ollama installed, you can make sure that Ollama is working by typing in Ollama serve, and then you can press enter. For me, it's already running on that port. and then you can showcase what are the models that are existing in Ollama by typing in Ollama list. And then in my case, I do have a number of the models that are installed on my machine. You can run whatever model you want, such as, so I'm going to say Ollama 3.2, 3 billion parameter model, by typing in Ollama 1, and then the name of the model, copy it and paste it, or type it yourself, and then press enter. It's going to take a little bit of time, and then write a simple code for argument's sake. And then it's going to spit out the response as you see fit. And if you want to close Ollama, you have two options. It's either you press Command and Q to stop the terminal, or /by. /by, it ends the Ollama instance. The last piece of the puzzle is Open WebUI. Open WebUI, as you can see on the screen, it mimics ChatGPT in terms of the interface, and it's fully integrated with Llama, and you can read all of the Ollama models inside of here, and you can chat with them, you can upload images, you can use the vision language models or the text-based language models. The installation of Open WebUI is fairly simple. All what you need to do is, in the terminal, you will type in pip install open-webui and then press enter. It's going to take a fair bit of time because it's going to download a number of gigabytes of dependencies for Open WebUI. And then in order to make it work, you can type in open-webui and then space serve and then press enter. It's going to take a bit of time to load all the dependencies, and then it's going to tell you that it is available on the local host 8080. You can go here, open a new tab and type in localhost and then semicolon 8080. Press enter, and then at the beginning, because I'm already registered in here, it's going to ask you to input a username and password. Don't worry, this is normal. It's local based. Just enter anything in the username and password. It's going to work perfectly fine. If you have some models that are downloaded already on Llama, you can find them here. So when I click on here, I'll find a number of the models that I have already exported to Llama. In continuation to part 1, I have built this Jupyter notebook with extra comments inside of it, an extra explanation to help you tweak your large language model and fine-tune it easily. So we have already covered how to install Homebrew. There's one thing that we need to do after installation of Homebrew, which is adding it to your path so that it works perfectly fine. There's an easy way to do this. All you need to do is you can copy these 3 lines of code, and then in any terminal window that you do have, you can paste them in and then press enter. And then we have already covered how to install Git on Mac. We also need to clone the GitHub repo of the MLX framework. So you can take that git clone and then the link of the GitHub repo, which I'm going to be putting the link for it in the description below. You don't need to type anything after me. Everything is in the Jupyter notebook, and then paste it here if that's the place where you need to put the GitHub repo. However, what I will suggest is go inside any of the directories that you want, and then you can right click in here and then open in terminal. If that's the place where you want to put the GitHub repo, and then you can paste the git clone, and then it's going to clone everything. We will need to go to one of the folders called LoRA. So there is an easy way to do it. Once you have cloned the repo, you can go inside the repo and then search for a folder called LoRA, and then on LoRA, you can right click and then open in terminal, and then you can type in whatever code you want. We want to make sure that pip is installed, so we can type in python-m ensure pip upgrade, and also we want to install the requirements. We can do that. Sometimes pip is not by default installed with Python. If you pressed on pip install -r requirements and it worked, then happy days. If not, then you'll have to install pip. Sometimes it tells you pip is an unknown command, so copy that command and put it here, and then install it first, and then after that you can install the requirements. We also need to copy the repo of Llama CPP. Llama CPP, it enables the end user to compress or convert the large language models to GGUF format or GGML format with different precision types, such as 16-bit, 8-bit, 4-bit, and the likes. So cloning the repo is going to be quite simple. You just need to do, again, the git in your preferred place and also install the requirements. I've already cloned the CPP. It's about 150 megabytes. And then you can go, and so the Llama CPP itself, you can open a terminal and then open in terminal, and then you can type in pip install -r requirements.txt, and it will install all of the requirements related to Llama CPP as well. The process of creating and preparing data for the fine-tuning is fairly simple. I have got the data in a CSV format. The data, as you can see on the screen, is composed of 3 columns: the ID of the row, the question, which is basically the prompt, and then the curated answer. I'm fine-tuning the large language model to be able to answer questions related to the summary of experiences for the Royal Institution of Chartered Surveyors for those candidates who are seeking the assessment of professional competence. The data itself is mainly composed of different competencies, and in each and every single competency there is a level. Level 1 is knowing, level 2 is doing, and level 3 is advising. The MLX, the way it works is that we have to have data of some sort, and then the data has to be converted into 3 JSON-L files: the train, the test, and the validation. For each and every single large language model, there is a chat template. In this instance, I haven't used a specific chat template. I have used one of them chat templates, which is provided by the MLX or in the MLX-examples in the GitHub repo. However, for different models, there are different chat templates. The chat template that you can see here is for Mistral. The chat template for Llama, it's a bit different because it has header ID, start of header ID, and end of header ID, and the likes. So I've used that chat template, which is a bit of a generic one provided by the MLX framework team, and I have created a Python code that takes CSV and it converts into 3 files: training, validation, and testing. The training data is 80% of your dataset, testing data is 10%, and validation data is 10%. And that is mainly the template that I have used. You can definitely change it however you see fit. You can use the Llama one or the Mistral or whatever it is. And I have 3 files saved here as a JSON-L file, which is that format. That is the format that is required by the MLX framework. The last thing that is related to the fine-tuning and the data is the download of the model itself. You can easily download whatever model you want. However, there are some models on the Huggingface website that are a bit hard to get. They are gated, they are behind a gate, and you need to access them. You have to make a request, and the request has to be reviewed by the owner of the repo, and then they're gonna give you or grant you access or not. So you have to install the Huggingface Hub library within Python, and you have to have a token. You have to get a token from the Huggingface website, and then in your terminal you can type in huggingface-cli login and then -token and then your token, and that's going to enable you easily to start downloading whatever model you want on the Huggingface website to your local machine, unless it's gated. The third part of our video is going to be all about the training of the model, testing it, and making sure that it's valid and that the responses that we receive make sense for our use case. I'm starting this part by having a decent and important block of code, which is basically defining the variables that I'm going to be using throughout the code instead of writing them again and again and again. So there are some directories that I'm defining, such as where the data is sat, which Hugging Face model I'm going to be downloading. In my case, it's Mistral instruct 0.3, and where I'm going to be saving that model. Also, if I want to upload the model to my Hugging Face repo, where would I put it? What is the name of the repo itself? What is the path of MLX converted large language model on my machine? Where would I save the adapters or the low rank adaptation parameters on my machine? Also, where would I save the fused MLX model with the adapters on my machine? Lastly, what is the name of the compressed fine-tuned large language model that I want? I've also added a system prompt to make it more detailed for the large language model itself when I'm doing the validation and testing the inferencing. And lastly, I am declaring where Llama CPP is going to be saved on my machine, because I'm going to do the quantization or the compression of the model into GGUF at the end of this tutorial. Having declared the variables that I'm going to be using for the rest of the code, it's now time to download any desired large language model, and in my case it's Mistral instruct version 0.3 with 16-bit accuracy. I have declared previously the Hugging Face token, and then I'm downloading the desired Hugging Face model using that token in a desired place on my computer, a local directory. And then we're going to be doing the conversion of the file that we have downloaded. So there is a function within the MLX framework, which is called MLX_LM LLM.convert, and here are all the arguments that you can find. So you can specify the Huggingface website or the Huggingface model path. What is the MLX path or the path to save the MLX model? And if you want the model to be converted and quantized, and what is the way for quantization as well, which is the accuracy, and if you're going to be uploading and converting to the MLX community, what repo or the repo's name, and if you want to save a dequantized or convert a dequantized model. So my model is already 16-bit. I don't need to dequantize anymore. The model itself is about 16 or 15 gigabytes. So I've run the MLX_LM.convert. I've specified the Huggingface model, which is in my case Mistral instruct version 0.3, and then that model, which is the Mistral, is going to be converted into MLX format, and it's going to be saved in my designed path of the MLX path. It converted the model. As you can see here, the overall size is about 14.5 gigabytes. Having created the data for the fine-tuning and also having downloaded the desired Huggingface model and converting it to MLX format, we now need to understand how the low rank adapters work under MLX framework. So there is a function called MLX_LM.LoRA. I have typed in -- help to understand the options that I do possess in this function. There are a fair bit of options, including where the data is sat, if you're going to be training the model itself, what fine-tuning you're going to be undertaking, is it LoRA, DORA, or full fine-tuning of the whole model, how many layers you're going to be tackling, what is the batch size, the more the merrier, but it comes at an expense of GPU or RAM space, how many iterations do you want to train the model for, what are the evaluation patches, the learning rate, and lots of other bits and pieces as well. The MLX.LoRA is quite interesting because it has also where to save the LoRa adapters, and it can also be used when testing the model itself. And not forgetting to mention that it is useful to determine what is the maximum sequence length that is going to be enabled by your model. And the larger, the more RAM you need or the more GPU you need. Graded checkpointing is also efficient for reduction of memory use. And going down, I've provided a fair bit of explanation about all of them parameters that I have used in my code. And here are what I've used. So stay in the MLX converted model here, and then where the data is sat, and that I'm going to be also training the model itself. I'm going to be doing the low rank adaptation for the fine tuning, number of layers and patch size. You're going to have to play with that depending on your computer. Number of iterations I put as 1000. I think 1000 is the default. I've also used the 1 × 10 to the power of -5 for the learning rate. That's I think the default one, and how many steps per report. Also where to save the adapters, how many saves or checkpoints we're going to have. So we have 1000 iterations, so this means we're going to have just 2 checkpoints, one every 500 iterations. My sequence length is 248. I've used grid checkpointing for a more efficient memory use. And as you can see here, I think it took me about 91 minutes, and the peak memory usage was in the range of 20 gigabytes. I have an M3 Max, so I have 128 gigabytes, so I don't have a problem with that peak usage. If you have a smaller memory, this means that more swap is going to be needed. Having finished the fine tuning after an hour and a half or so, it's now time to test how good or bad the adapters that we have from the LoRa. The MLX_LM.LoRa, it has an argument which is called test. The test, it tests both the loss and perplexity. And as you can see on the screen, there are some limits or some ranges for the loss test and the perplexity test. I have got, I would say, about an average score. So for the loss test, I got about 4. So the range is from 1.5 to 5. I've got about moderate performance, thereabouts. And also for the perplexity, I got about 51%, which is still moderate. In the code itself, I've specified which model, which is the MLX converted model, what data I had, which is the JSON-L files, and then where the adapters were sat, and then testing it. And the test, it took me a couple of seconds, about 6-7 seconds, and these are the results as shown above. And then it was time for the actual validation, going through the inferencing. So there's one function in MLX, which is called MLX_LM.generate. I then typed -- help to understand what are the key arguments. And the key arguments in the test also, they are quite interesting, because you're going to have to specify the model, where the adapters are sat, and then if you have extra end of sequence tokens that you want to put to stop generation, that's going to be quite helpful for chat completion purposes. What is the system prompt? And that's why I have defined it up top. What is the actual prompt that you want to ask the model, the maximum number of tokens, any temperature, the lower, the more accurate the model is going to be, and the higher, the more creative the model is going to be. Top P and top N, that's going to also affect the choice of the words, how many words are going to be chosen based on their probability. And also, if you want the model to be verbose, by showing the actual processing that is happening behind the scenes. And a number of them are the bits and pieces and other arguments that you can have a read of. I've explained here thoroughly what I have done and why I've done it. You can have a read at your own time. The code itself was MLX_LM.generate. I have specified the model itself, which is the MLX model, which is the Huggingface model converted to MLX format, where the adapters are sat, what system prompt, which is basically you are a person who is specialized in the RSS APC stuff, and that you are trying to help candidates answer their questions and nail the submissions and be specific to what's happening in the UK, the RSS guidance notes and the likes. And then the prompt, that is a very classic prompt. Give me an example of one of the competencies at a specific level. And it's very good because level 2 is all about the doing. So from what I can see on the screen, it says being involved, I worked in, I've been involved, which means that there's some sort of engagement. So level 1 is knowing, which is I gained understanding, and that's it. Level 2 is doing, I did, I involved, I envisaged. Level 3 is all about the piece of advice given to the client. So that one is accurate, fairly accurate. And you can see some metrics and statistics here. I've also tried to test it one more time by going to level 3. I wanted to see if there's the word advice. So as you can see here, I've advised, I worked on some bits and pieces, and then I advised. So that is accurate. The same competency, different levels. I then wanted to test it again for a different competency. I liaised and advised. So yeah, that's fine. Level 3 for contract practice, that is completely accurate. No problem whatsoever. And then you can see here the peak usage, some metrics about the tokens per second for prompt and generation, which is good quality. Having trained the model, it's now time to fuse the trained adapters to the MLX model, create a fine-tuned model, and then convert that fine-tuned model into a GGUF format using the Llama CPP. There is one last function or line of code that we need from the MLX framework before jumping to the conversion, which is called the MLX_LM.fuse. I typed in --help to understand the arguments that lie within this functionality or this function within the MLX framework. So it allows having a model which is going to be fused with the adapters. So state where the model needs to be saved, state where the adapters are saved, state where the actual model that is saved. And you can also state the Huggingface repo of the original model, which is in my case Mistral 0.3. And if you're going to be uploading the fused model to GitHub repo, you can also choose within MLX whether to have a dequantized fused model or a quantized. However, as you can see here, the default or basically the only available option in the quantization within MLX is 16-bit, which is quite large. Think about the larger models such as Llama, 70 billion parameters, or Falcon 40B. This means that MLX framework is not the greatest when it comes to conversion into GGUF format, hence the usage of llama.cpp. I cracked on with the conversion itself, or the fusing of the adapters with the model. I stated where the MLX converted model or the Huggingface model converted to MLX is sat or saved, where I want to save that fused model, and where the adapters or the trained adapters from the previous step are saved. And then I wanted to make sure that the model is dequantized so that I can quantize it. When I did that, I needed to make sure that the performance of the fused model, which is the final model now, is on par with the adapters, because there was one of them problems that I've seen on the MLX framework discussion pages on Reddit and on GitHub, which is the adapters, when they are not fused to the main model, they are performing absolutely fantastic. However, when the model is fused with the adapters, the overall fine-tuned model is less performing than the adapters. Hence, I wanted to try out the fused model first before going with the quantization. So I used, again, the generate function within the MLX framework. I'm now using the fused model and I'm stating the same system prompt, which is you are an AI that is specialized in QSing in civil engineering and answering RICS APC questions, and then I'm asking a question related to level 3. I have seen that it managed to get the word advice. I've been able to advise, I've been able to advise, I've been able to advise. It is accurate. The size of it is about 14.5 gigs, and it can process the tokens pretty decently. The generation is about 25 tokens per second, and the digestion of the prompt is about 640 something tokens per second, which is good. And also, I wanted to check the model. How good is it if we're going to be using the Python API, not just the generation function within the terminal? If I want to embed this model into an actual chatbot that I'm going to be writing the code for, how good or bad it is. So I've used the protocol of the MLX framework that is available on the Huggingface website. So I've copied and pasted that whole code. What I changed is where the model is sat and what is the prompt. So load the model and tokenizer from the fine-tuned MLX model and apply whatever chat template if existing. If not, then use the classic chat template. And I have a prompt here that is dealt with in the content, and the response is generating a response based on the prompt, based on the model and its tokenizer, and be verbose about it. So the question is about construction technology level 3. I provided the client with the relative pros and cons, which is a piece of advice, as well as providing examples for the key materials, and I advised the client about whatever it is. So the model is fairly accurate, whether you're going to be using it in terminal, which means that it can be embedded in Ollama, which we're going to be exploring in a little bit, and it can also be quite accurate if you're going to be embedded in a chatbot from scratch, even if you're not going to be using the chat Ollama library within Python. Following from the previous steps, it's easy to upload a fused model to the Huggingface website. You can upload your model using the fuse function within the MLX framework, where you can fuse the original model, which is the MLX converted model, with the adapters, the trained adapters, and here state in on what original model the fine-tuned or the converted model is based on. In my case, it was the Mistral, and then what repo you want to upload to. And I made sure that the uploaded one is dequantized, which means that it's uploaded with the same accuracy. In my case, it was 16-bit and it was uploaded as 16-bit. The fuse process didn't take a lot of time, took a couple of seconds. The upload took a little while because it's about 15 gigabytes. Before we jump to the last piece of the puzzle, which is Ollama.cpp, taking into account the local conversion of large language models from safe tensors format to GGUF format, I'll show you how you can do that online. So if you have uploaded any of your models to the Huggingface website, there is a repo on the Huggingface called GGUF my repo, which is basically the Llama CPP but on the web. So you can sign in with your Huggingface account, choose whatever model you want, for argument's sake, and then choose whatever quantization method you want. And then you can state whether it's a private repo or not, and it will upload automatically after you hit the submit button your GGUF desired model, let's say it's 6-bit quantization, into your repository with the name of _GGUF K6 _K. So that's how you can do it if you have uploaded on your Huggingface repositories. If you want to do it locally, as we have explained in the first part of this video, we have to download or clone the repository of llama.cpp. Once we clone the repository, we can then change the directory to be within the place where llama.cpp is cloned on our computer. And then there is a file called convert the Hugging Face to GGUF. I have typed in -- help so that I can understand what arguments are there. The main arguments that I was really interested in is specifying the directory containing the model file and specifying where the converted file is going to be sat and what is the type of the conversion, alongside the being verbose or not, and the no lazy mechanism, which uses more RAM but for more accuracy. And that's basically what I've done here. I have activated that file, so Python 3, and then I activated the Hugging Face file to GGUF. I've stated where the fine-tuned model is sat and where the compressed GGUF file is going to be sat, which is within the same directory really, and then what type of quantization, so it's Q8, and I use the no lazy option and then verbose so that I can see the processing that is happening here behind the scenes. I would say it took about a minute or so to convert the whole model because it's saved locally on my machine, and as you can see here, it's about 7.7 gigabytes. It's an 8-bit quantized model. Once you have converted your model to GGUF, the last piece of the puzzle is basically using it in any chatbot. So the chatbot of choice is Ollama, or the system of choice is Ollama, which allows chatting with large language models locally on one's machine. In order to do that, we have to create a model file so that the fine-tuned model is more accurate when it comes to chatting with it. So there are four main things that we need to focus on when creating that model file. So you can create a model file easily as a txt file, but then remove the txt from it. The first argument that you have to put in the file is from, where the file is sat, the Q8 quantized or Q16 or whatever it is, and then what parameters are going to be put in. So there are some parameters that I was put in my case, such as the temperature and the CTX. The third thing is the template. So where you get the template, that is really easy. You can go to Ollama, and for the purpose of our model, it doesn't really matter which variant of Mistral, you can find the parameters here, which I have taken a copy of. So where to stop. I have added the temperature because I want it to be realistic. I don't want any creativity in the response. Concerning the template itself, you can go to the template, and what I've done is that I've copied and pasted that under the word template with 3 inverted commas here and 3 inverted commas here. And then the system prompt, which allows the large language model itself to be more clever and more accurate when providing responses. Mistral doesn't have a specific system prompt because it depends really on the end user. You can do whatever you want with it, and I've stated here the system prompt that we have used above. And once you have the model file up and ready, you can then export the model easily to Ollama, where you can go to where the file is saved. My file was saved here, all the saved instance files, which is Mistral 7b instruct, MLX fine-tuned, and I have here the model file. What I'm going to be doing is I'm going to be taking a copy of that file without the GGUF, click anywhere in the folder, right click here, open in terminal, and then I'll say Ollama, and then the name of the model that I want, and then -f, and then model file. Once you press on enter, it's going to take a couple of seconds to create the file. I have already done that, so you can see my list of models. You will see the RICS here, APC master, the Mistral 7-bit instruct. That's the name I've chosen for it. It was done a couple of days ago, and it's 7.7 gigabytes. It's an 8 billion parameter model. Once you do that, you can easily chat with it even here in Ollama. Then you can type in Ollama 1 and then the name of the model. It's going to take a bit of time, and then you can ask it, give me a good quality example, competency, procurement, and press enter. It's going to be spitting out everything now. Yeah, so it's fairly fast. So I was able to apply for a Secure Life project. I did, and the likes. I was responsible for compiling the brief, the client, and the likes. Yeah, so it's cool and concise. And definitely when you're drafting your RSS APC, it's going to need a couple of examples, so you'll have to run this a couple of times. Having done this on Ollama, you can go easily to Open WebUI, which we have installed at the beginning of the video, and then you can press on refresh here. It's going to refresh the models that you have. You can choose whatever model that you want. I've already done that for the purpose of this video, AI for RSCS, APC, MLX. And then I've asked a couple of them questions for procurement and tendering level 2. So I gained the experience, I've also reviewed, and then for level 3, you will find that it did some advice. As you can see, I advised the client, and then procurement and tendering level 1 throughout my education of gained understanding. So that's completely accurate. Definitely, it's not 100% accurate because when we did the loss test and perplexity test, it was moderate. So definitely more data is going to be needed, and maybe tweaking in the chat template, but that's for future releases. And that's how you can download a Huggingface model, convert it to MLX, create your datasets, fine-tune your MLX converted model, and then fuse it with the training adapters, and then convert the final fine-tuned model into GGF format for usage on chatbots such as Ollama and Open WebUI. Thanks a lot for watching. Hope you found this video useful and insightful. I've prepared a couple of them other videos about fine-tuning large language models and deploying them to Open WebUI. I'm going to be putting the links in the description below. You can also pay my website a visit at www.apcmasterypath.co.uk, where I provide multiple packages for the RSS APC candidates to support them throughout their RSCS journey. Also, I provide lots of insights about the RSS APC process, the different areas of competence, and how you can deploy AI within the construction industry. Do not forget to hit the like button and subscribe so that you get notified about our latest videos.